So today we're really going to dive into solving two-step equations. We started it yesterday. There was a brief introductory video, and I did one of the examples on a Zoom call with you. But today we're really getting into these. The beginning of the week, I'm sure you were probably a little bit bored with some of the equations I gave you. The one-step equations were very straightforward, often could be done with mental math. By the time we get to example 4 of this video, you're going to be scratching your head. We ramp it up very quickly in how sophisticated these equations are. So these are called two-step equations. They are going to have two operations in them, either an addition or subtraction and a multiplication or division. My advice to you is to just focus on one piece at a time. Don't be overwhelmed. Don't try to do too much. Just do one thing at a time. So how do you know where to start? My advice is that you undo PEMDAS. Okay, so if PEMDAS is, please excuse my dear Aunt Sally, parentheses, exponents, multiply and divide, add and subtract, we're going to do that backwards in order to undo it. So the name that I've given it is SADMET. So you will undo addition and subtraction as the very first thing that you undo. I'm trying to get this where it's supposed to be, and my alignment from my iPad to the actual video is a little bit off. I'm just going to erase that. So subtraction and addition will always be undone first, then multiplication and division will be undone. Another way that you can think of this, and if I had people in front of me, I would have you act this out. Things that are loosely attached, and I've used that word attached several times in our equation unit, things that are loosely attached are what get undone first, and things that are tightly attached get undone later. So if we were together and I could have students, I'd have two students kind of like lock arms, like you were going to do-si-do and swing each other around. Those would be tightly attached. And then somebody else just kind of standing there poking one person in the shoulder, that would be a very loose attachment. Easy to knock that person away and say, stop touching me, where the other person is held on very tightly. All right, let's get into some problems. Here is an example of a two-step equation. 2x plus 3 equals 9. And when I was just talking about those tightly attached things, I would argue that 2x are tightly attached. They're multiplied. They're actually stuck together so tightly they don't even need a sign. And this plus 3 would be more loosely attached. It's not stuck to the x as closely as the 2 is. So we're going to get rid of that 3 first. Okay, let me get rid of my scribbles here. All right, so we're going to split this. We still have two parts to the equation. We've got the left half and the right half. They are equivalent values. They just look a little different. Okay, so if you think about SADMEP, we are going to undo the addition and subtraction first. So right now I've got addition. How do I undo that addition? With subtraction. And what you do to one side, you do to the other. Okay, 3 minus 3 is 0, which is great. That's what we want. We want it to go away. We're going to bring down the 2x because I haven't done anything with that yet. And then we'll calculate over here, 9 minus 3 is 6. And now we've turned it into a one-step equation. No problem. We'll breeze right through this. This is multiplication, so I'll divide and divide. 2 divided by 2 is 1, leaving me 1x. And 6 divided by 2 is 3. I think x equals 3. Now, I've put the sticky note over here, mostly because I wanted to play with the sticky notes, but I put the sticky note over there because it's a really good idea to do the check step. I know it's a pain. Nobody likes to do it. It's extra work. It's worth it, especially in the beginning when you're learning these, or if there are fractions or integers involved. You will find if you make a mistake, you'll catch it and be able to fix it. Okay, so how do we do a check step? You take the number that you think is the answer and you substitute it into the original. So here I think x equals 3. Everywhere there's an x, I'm going to replace it with a 3. So I keep my 2, multiply by 3 because 2x is multiplication. The rest of the equation stays the same. Keep the plus 3, keep the equals 9. Then you just have to go through and check it. 2 times 3 is 6. 6 plus 3 is 9. Because those two are equal, your answer is right. Come on, you know I gotta play with all my little toys here. Move the arrow, move the check mark. There you go. I feel better now. Okay, let's go on to our next example. So 3x plus 2 equals 23. We're going to split it at the equals. I didn't move to the next one, so sorry. 3x plus 2 equals 23. Split it at the equals. Again, I start with the addition and subtraction. So I'll subtract 2, because I'm going to undo the addition that I saw from the original problem. Bring down what I didn't use. Calculate on the other side. Divide because I see multiplication. 21 divided by 3 is 7. Take that extra second and do the check step. I'm going to use parentheses for multiplication. Just to mix it up, that's a 2. Sorry. Three times 7 is 21. And then 21 plus 2 is 23. So we're good. All right, now don't be alarmed at this next problem. It starts to get ugly quick. It's a beautiful problem. Makes me all kinds of happy. So we do have some integers involved here, but our process is exactly the same. Split it at the equals. Undo addition and subtraction first. So this subtraction here will be undone by addition. -7 and +7 together equals 0. I'll bring down the -2x. Be really careful that that negative comes with it. And then 7 plus 3 is 10 on the other side. Again, we're at a one-step equation. This is being multiplied, so I'll divide, keeping that negative sign. Now, -2 divided by -2 gives me a +1, or a +1x. On the other side, 10 divided by 2 is 5. There was one negative sign, so my answer is -5. Be really careful when you do your check step. The only thing that we're replacing is the x. Everything else will stay exactly the same. So -2 times what I think the answer is, -7 equals 3. So many negative signs. -2 times -5 is +10. 10 minus 7 is 3. And 3 equals 3. So I'm good. All right, one more. We've got negatives, we've got fractions, we've got things that are reversed. This is a different order than we've seen in the other problems. Steps are the same. So we'll split it at the equals. Addition, subtraction gets undone first. Now, you're going to see this plus sign right here, and you're going to think that you want to get rid of the 1/5, but not yet. Because remember that the 1/5 is held together very tightly to the R. This 4 is kind of like hanging out, like keeps poking you in the shoulder. It's real easy to swat them away and be like, leave me alone. Okay? But if this was the person that you were linking arms with, you're connected much more tightly, and we're not ready to get rid of that 1/5 yet. All right? So we are going to undo this 4 with subtraction. This is really a +4. So to get it to go to 0, I need to do the opposite. So if I subtract 4 on the left, I'll subtract 4 on the right. We had a positive and a negative, which goes to 0. I'll bring down the 1/5 R. And then on the other side, I have two negatives, so they'd be the same colored chip. Add them together, I get -5. Again, we're at a one-step equation. Yeah, it's got a fraction, no big deal. So right now, these are being multiplied, so I would have to divide. But I don't really like dividing by fractions. Instead, I can multiply by the reciprocal. We'll flip 1/5 to the reciprocal of 5/1. What I do to one side, that's a multiplication sign, I must do to the other. So over here on the left, we'll have 5/5. which is 1 or 1r. And over on the right, we'll have 5 times 5 and 1 times 1 with a single negative sign. So I think my answer is r equals 25. Let's check. Keep the 4, keep the plus 1/5, change this to be negative 25 equals negative 1. All I did was replace this r with the negative 25 that I calculated. I can put a 1 on the bottom since I'm going to be multiplying fractions. Why isn't that one right? There we go. So we're going to do negative 25. Let me do this down here. 1/5 times negative 25 over 1 is negative 25 over 5. That will simplify to negative 5. I did a little bit of a shortcut there by not including that calculation. Then I say 4 plus negative 5 is negative 1, and the two sides are balanced, so I'm good. Now, I do on the next slide want to show you what happens if you get an incorrect answer. So let's take that same problem that I just had. I had 4 plus 1/5 r equals negative 1. I did all the work, blah, blah, blah. Let's say I got r equals positive 25. I forgot my negative sign. And I want to be very clear that this is the wrong answer. All right, so when I go to do the check step, and I'll even switch colors so you can tell the difference. When I go to do the check step, I get 4 plus 1/5 times 25 equals negative 1. This is going to be 5. Last time it was negative 5, if you remember. When you go to do this, 4 plus 5, go ask any kindergartner, 4 plus 5 is 9. And 9 is not the same as negative 1. Having $9 in your pocket, owing somebody $1, not the same situation. So because these two were not the same, this answer is not correct. So then you have to go back and check your steps and see if you can figure out what went wrong, right? If you get a situation like that where your answer here is not the same, your answer is not correct. We're going to do lots of practice with these. Please, please, if you have any questions, reach out and ask so that I can get you through this. And we'll continue into next week with a couple of other styles of two-step equations.